Okay, we should be good. Okay.
Now it's too late to uninvite me, Tom.
Good evening. Hello, welcome, welcome. I'm so pleased to see this great turnout for this sustainability lecture. And so I am Susan Chelangoski, and I am the interim vice president of academic affairs. So basically in charge of academics around here. And this is one of the fun things that I get to do, and that's to welcome folks to campus for events like this. This is the 13th iteration of the William Issa Endowment Speaker Series, and thank you to everyone for coming tonight. The William Issa Endowment was created by Daryl and Kathy Issa to memorialize their nephew William Louis Issa. And so we're very pleased to have these every year, probably with a little pause in COVID. And we're really, really happy to be back together and in person. So this is put on by the Sustainability Committee, this talk. And Dr. Tom Wasmer, who is the chair of this committee, is going to introduce our speaker for this evening. So thank you, Dr. Wasmer.
Good evening, everybody. Dr. Lemos received her bachelor's in science in economics from the Universidade Federal de Juiz de Fora in Brazil. Close. I practiced, but I heard it and I didn't do it right. And her master's of science and PhD in political science from the Massachusetts Institute of Technology. She has been working at the University of Michigan since 2002, first as an assistant, then associate, and since 2012 as a professor of natural resources and environment. In 2015, she was the associate dean for research and engagement at the School for Environment and Sustainability. From 2006 to 2007, she was the James Martin 21st Century School Fellow of the Environmental Change Institute at Oxford University in England. In 2014, Lemos was lead author of the Intergovernmental Panel on Climate Change, their 5th assessment report, and in 2018, of the 4th US National Climate Assessment. She is a co-director of Great Lakes Integrated Science and Assessments since 2016. Dr. Lemos' research focuses on climate adaptation and especially the role of actionable knowledge, the relationship between anti-poverty programs and risk management, adaptive capacity in drought planning, water management, agriculture, and urban planning, and the impact of technocratic solutions on democracy and equity. Maria, it's a real pleasure to have you with us tonight.
Thank you so much. They told me that I have to stay close to this microphone. I'm trying to move it a little bit because I'm a walker. Lecterns don't go well with me, so I'll try. A satisfying solution. Not perfect, but good enough. Okay. Okay, so I first want to thank you, Tom, the university, all the students, all of you for this invitation. It's an honor. I love to come to events like this and especially talk to younger people to whom I'm indebted for this word that I'm leaving to you. All the management and all the tending and stewardship that you guys will have to engage to right our wrongs of my generation and generations before me. So to you, my good luck, and really, really thank you for taking this on from now on. So climate change, for me, it is the existential problem of our generation because it will affect everything. It's already affecting so many of the things that we do and the way that we behave. It will affect it even more. And everything we hear about climate change is how it's getting worse, how it is accelerating, how it's becoming costlier, and the urgency for the need for us to do something about it. In the Great Lakes region, we are actually mildly lucky because we are not so exposed to the most egregious impacts of climate change. What I'm going to be talking here is not about the problem of climate change or mitigation of the problem of climate change, but focusing more on how we respond, address, and adapt impacts of climate change that are already happening, and we are already scrambling to keep up with and not doing a great job. So let's just think about the last 2 years. Everything that we heard about climate change was horrible, wasn't it? It was about the problems in Florida with flooding, with the hurricanes, super drought in California, 1,000-year drought. That is scary, isn't it? 1,000-year drought seems like something so ominous, so important for the future of both people, but also of ecosystems. We also heard about sea level rise, loss of coast in the Great Lakes, a lot of erosion, and all of the other things that are still coming our way. Heat in Europe, people don't know what to do with too much heat. They don't know what to do with too much snow. Look at what we are happening with us this year. It's a weird winter, isn't it? A little bit too warm, but then again, there's horrible Arctic bombs and all those very, extreme snowstorms that we are having. So this is climate change. It disorganizes the system. It's not one thing. It's a multiplier of threats. We have all lived with those threats our whole life. We understand snow, but climate change is multiplying those threats in ways that we don't understand very well. And acting upon it is the difficulty right now. So that's what I study. I study how to act upon it. So this talk today is about this concept of adaptive capacity. If we have to respond, we have to prevent, we have to manage, and we have to adapt, what are the tools that are available to us to do that, and how we grow those tools, how we increase our capacity to adapt. So climate vulnerability is the predisposition that we have to be affected by changes in weather and long-term climate, okay? So everything that climate does that makes us more exposed to threat, to risk, is in the concept of climate vulnerability. Climate vulnerability is a function of three main things. So that is the science, the social science of climate vulnerability. Is a function of exposure, which means what is the dimension of the threat to your livelihood? So this is about the strength of the hurricane, the size of the drought, the geography of the extreme events, where you live, who you are when living on those places, are the external parts of the impact of climate change. Is what changes in climate that affects you. That's exposure. During COVID, we got very familiar with this language of exposure, isn't it? How do you expose yourself to COVID? It's the same thing. The second part, the sensitivity, which in the case of COVID would be how things that are about you make you more susceptible to get COVID. You remember, if you're older, if you had heart condition, or if you had COPD, any kind of precondition, you were more susceptible. Climate change is the same thing. Who you are and what frailties or what capacities you have make you more exposed, more vulnerable to impacts of climate change. And adaptive capacity is the positive part of that equation, is the assets that you have that you can mobilize to minimize your risk and to respond to risk and impact when it happens. So if I live in a better house than a more frail house, I have more adaptive capacity than somebody who lives in a trailer park, for instance, that is much more likely to be affected by a hurricane. Or if I have the means to leave an area that is under drought or under flooding, then I am less exposed. I have more capacity. If I'm younger, I have more capacity than older people. If I'm healthier, I have more capacity than people who are infirm or cannot move, for instance. So adaptive capacity is about this condition. But adaptive capacity is something that you don't know what it is until something hits you. So it's a latent situation. You don't know what it is. I like to tell this story about adaptive capacity, which is a little story, but it's personal to me. I grew up in a city in Brazil where it rained every day. That's what happened in my city. Every day, everybody carries an umbrella. You have your wallet, your glasses, and an umbrella everywhere you go. So when I moved to the US, I gallivanting a little bit, Boston, lived in California. The umbrella was a little bit odd, but it was not weird. I still carried my umbrella in my backpack. Then I moved to Arizona. I moved to Tucson. And after a year of carrying my umbrella and not seeing one stitch of rain, I moved the umbrella from my bag to my car, to the back of my car. And I said, okay, it's there. If I need it one day, I will have it. The only day that ever rained in Arizona, in Tucson, while I was there, everybody was running like crazy because nobody had an umbrella. And I said, oh my God, I have an umbrella. What a smart person. I am the only person in the city that has an umbrella. So I went to get my umbrella. When I opened my umbrella, it was in the sun and in the heat in the car for so many years that it completely came apart. That's what adaptive capacity is. I thought I had it. When I needed it, it was not there for me. So a lot of the problems that we have with adaptive capacity is this condition that I don't know if we have enough. You may protect your house, you may weatherize your house, you can board all your house in a hurricane, but if the hurricane is very big, it might take your whole house away. So just protecting yourself will not be enough. So the uncertainty related to this concept is what makes it so difficult. So how do we build it? So we can build it in many different ways. Theoretically, we can think about those capacities as different kinds of assets that you have. You can think about generic capacities. Generic capacities are the capitals, the assets that are available to you. So it's better to have money, it's better to have education, it's better to have safety, it's better to have transportation, it's better to have a political system that helps you to resist climate change and recover from that. Those are generic things. Those are non-regret assets. If you have all of those assets, you are very likely to be better off than not having them. Okay, so they are generic because they are disposable. They will help you to resist to many different things. So if you think about a health crisis like COVID and climate change as an environmental crisis, all those assets are as good for COVID as they are for climate. Having more education, more money, shelter, ability to move, all of those things that are generic. However, there are other kinds of capacities that are very specific for climate change. They are not generic that can be applied to any event. And those usually are more complicated to get. So if you have a levee in your city, you are more protected than sea level rise exposed cities that have no protection whatsoever. If you have a good stormwater system, you are much more likely not to suffer with flooding than if you have no stormwater system whatsoever, or a bad one, an old one, or a dilapidated one. If you live in a city that has resources for emergency help, you are much better than in a city that does not have those emergency services. So those are very specific. In order to build your overall adaptive capacity, you need both. You need a combination of those two things. A lot of my research is trying to understand those combinations. Because like a lot of things in life, when you have too much of a good thing, it can also be bad for you. Chocolate is very good in small pieces. If you eat a whole kilo of chocolate, I've tried, not good for you. you feel bad. So how do you combine those capacities in a way that you hit that sweet spot that allows you to be the most responsive to a threat, to the impact of climate change? So an example of this would be, in theory, the more generic capacity that you have, the better off you are. So it's a linear relationship. If you have more money, more education, more safety, better politics, more democracy, better culture, you are better off. But there may be an inflection point on how much having those capacities will help you in any situation. Then you might have that inflection point in which an over-reliance on those capacities actually might start to make you a little bit more vulnerable. And you might get to a point in which it just doesn't work. It makes you more vulnerable. So Katrina is a very good example of a situation like that. So when the Hurricane Katrina hit New Orleans, it was a very strong hurricane. It was very bad for a few days, but because New Orleans have had many, many hurricanes before and knew how to respond to hurricanes, knew how to evacuate people, knew how to move people from lower ground to high ground. And they had those very, very impressive levees that held the water from the neighborhoods. They felt that they could ride that storm. So they had so much generic capacity and so much specific capacity because they had protected themselves so many times from flooding and hurricanes before that there was a little bit of a complacency. When the levees did not hold the water, then the whole city got underwater. We call that the safe development paradox. When you are so developed, you develop so much of your assets that paradoxically, that makes you a little bit more vulnerable because you don't think that it's going to happen to you. This is the same thing of people who have had so many hurricanes that they say, oh, I'm not going to leave, I'm going to ride this storm. And then they stay in and they die. That happens in Fort Myers last year on the big hurricane in the Gulf Coast of Florida. So all of those things are research for me and are horrible practice for all these people who are impacted by this kind of event. So this is the theory. So this is what we study. So we have a lot of projects, a lot of people in the world trying to think about those relationships, how to run experiments to understand better those relationships, try to understand how people respond to different events so that we are better prepared the next time that they happen. So I'm going to give you an example of a little bit of a research that I do in this area on building adaptive capacity. The first project that I'm going to talk to you about is in Northeast Brazil. I've done this project from 1998 to 2018, almost 20 years. And now I have closed that part of my research life, but it is a long-term project. So we started this project trying to understand how poor farmers in Northeast Brazil, which is one of the driest regions in the world, is a semi-arid area, how they were responding to more severe and more frequent drought because of climate change. So it was a long-term project in which we interviewed people through the years to try to understand what was changing in the way that they were responding to drought. So we started in '98, looking at how people used seasonal climate forecasting, El Nino forecasting, to try to make an educated decision on why and how and when they would plant in a dry season. So these are very, very poor households, $1 a day, very, very poor, under the poverty line. They also are very small households in terms of land tenure, and they are 100% dependent on rain. They don't have irrigation, which makes them even more exposed and more sensitive to drought. Okay, so this is a picture of a very famous Brazilian photographer, Sebastião Salgado, who really has a beautiful book about Northeast Brazil. So I started studying the use of information from households to protect themselves. If they knew what was going to happen, were they able to respond by understanding if the drought was going to be more severe or not? And I ended up studying poverty, to be honest with you. Because what I found out in the first phase of this project, that even if those households knew exactly, which they never did, but even if they knew exactly how strong and how long the drought was going to be, they could never respond. And the reason that they could never respond, because they didn't have the means to respond. They didn't have the generic capacities to respond. It's not as if they would say, okay, I'll move in with some friends somewhere else if the drought is bad, or I'm going to have access to irrigation if this drought is bad. So the only thing that they could do is to plant the same thing, which is beans, corn, and manioc flour, manioc plant, every year, and pray for rain. If the rain did not come, they would lose their crops and they would face famine. So information, they cannot eat information. Information was completely useless. So we are all making all this sophisticated research in the US, trying to project and to forecast drought, no outcome, because they could not respond. So theirs was not a problem of specific capacity. Theirs was a problem of generic capacity. They didn't have the minimum level of assets, of goods, to be able to respond. So it was a problem of poverty. In the beginning of the 2000s, the Brazilian government started a very aggressive anti-poverty program that is called the Family Fellowship, or the Family Voucher, Bolsa Família. And this was a program in which every household that had children in school age would get a minimum of a voucher, welfare, from the government if they kept their kids at school. Because many of those families, what happened is that as soon as the children could hold an implement, an input, they were put to work on the fields because there was no other option. So what the government told them was that if you keep your kids in school, I will pay for you not to use your fields in the field. So I'll pay for you to keep your kids in school. When the kids were in the school, first of all, they could eat because they would eat in the school. But also a second condition of this voucher was that they had to have prenatal care for pregnant women and health care for kids until 2 years of age, because infant mortality was extremely high in these communities. So the government wanted to avoid infant mortality. And one effect of infant mortality, because the kids die in a much higher frequency, people would have a lot of kids because they were trying to replace the kids. So it's a vicious cycle of poverty and bad decisions. So what the government tried to do is to stop this program by having a social protection program, which gave everybody some cash. So one of these projects was to look at samples of families that we started talking to in 1998 and then compare their lives before the program and after the program. So it was not a longitudinal study because we couldn't find exactly the same families, but it was a panel statistical modeling program trying to understand how their lives had improved and if improving their lives made them less exposed to drought. So this was between two droughts. One drought in 2000, the program started in 2000. There was a drought in 2012, and we collected data in 2014. So it was a natural experiment that worked very well for us to understand. What we found is that there was tremendous amount of improvement on those households. The fact that they had money for basic goods, which was food, basically, meant that there was much less famine during a very severe problem. The children were in school, which was an improvement on their livelihoods as well. And families were much better off because of a very small contribution from the government in terms of welfare. What were the negative outcomes of the program? A lot of families actually were not planting anymore because there was no reason for them to do so. And that creates other kinds of social problems. There was an increase in indebtedness because when you have cash, you can buy in credit, and therefore people had more debt. They were more anxious many times. There was, of course, room for fraud. There was a lot of things that are bad because cash comes into a community. But in terms of the most egregious impacts of climate change and drought, they were 100% better, literally. Some households more than 100% better in terms of their capacity to adapt, because they had some of their needs met, and then they could then make better decisions about their future. Long term, the program fell very short because the education system was not very good. What was the theory of change of this program, especially in relation to poverty, but also to climate change? If the children stayed in school, they could then move to a livelihood that was not the same livelihood than their parents had. Because this kind of agriculture, it will disappear. It will disappear because it cannot survive without irrigation. And there is not enough water in the system to irrigate all of those fields. So this agriculture is not about economics, it's about social problems. You don't know where to put all, so in the state of Ceará, where we did this research, this small agriculture was responsible for 5% of the GDP, of the gross domestic product of the state, but employed 38% of the population. So it was not generating any wealth. It was just keeping people from moving to other areas in which they would be poor as well. So it was a social issue, not an agricultural issue. So this is adaptation for you, okay? So there is adaptation in the short run. People should not be hungry, and therefore it's our moral obligation that they are not hungry. Climate change is increasing the threat of hunger, and therefore we have to take care of this problem. But in the long run, adaptation will mean wiping out this kind of agriculture. This kind of agriculture should not exist. But for it not to exist, you have to have employment. You have to have an alternative livelihood that is better than this livelihood that they have, that is viable under climate change. That is the crux of adaptation. How do we create these conditions for that to happen? So in Northeast Brazil, those results were very positive in the short run. They went bad again because there was a new president that sort of destroyed that program. Now there is another new president that is bringing the program back. And that is the second big issue of climate change adaptation, politics. Very, very complicated to deal with politics. The politics of climate change are very weird, as we all know. There is a lot of people who don't believe in climate change. There is a lot of people that are skeptical about it, climate change. There are a lot of people who believe in climate change but think that we should not do anything about that. And that is a problem that is much more prevalent in the US than in Brazil, where most people believe in climate change. So here we deal with the different kinds of issues and different ways to think about on how to build capacity. In the Great Lakes, knowledge is very important because we have a lot of the generic capacities that we need. But the problem is the political will to do something, or the ability and capacity from governments and decision makers to do the right thing by climate change. I'm not getting into the politics of climate change with this audience, but I'm telling you that that is the work that I do in this organization called GLISA. So GLISA is the Great Lakes Climate and Scientific Assessment. It's an organization that is funded by NOAA from the Department of Commerce, which is the agency in the US that takes care of the atmosphere, the oceans, and air. Very big scope. So NOAA has created several centers around the US, which it funds well in increments of 5 years to try to understand how increase the use of climate information in adaptation, increasing the capacity of decision makers in the US to adapt to climate change. my DRISA, my organization, the organization that I am the principal investigator of, serves the 8 states in the Great Lakes plus the province of Ontario, because it's all the states that have a border with any of the Great Lakes, okay? So it's a lot of people. This is just like a snapshot of all the sectors that we work, all the states that we serve, and the different geographies where we have collaborators with different people. So what is the premise of this? That if you have better information, you make better decisions. And if that information is available, feasible, and adaptive, you have more adaptation. So that seems very commonsensical, isn't it? If I have better information, I make better decisions. That's not true. You know, many times you have too much information and you are paralyzed by having too much choice. You can't make no choice. You know, you can't make any choice. Sometimes you have the wrong information. There is a lot of information, but it's not the right information. And we have to understand that the value of information is not neutral. It's also based on this idea that it needs to fit the decision that you need. So what we do in the university, we create a lot of information. We create a lot of information. We teach you, you get like a smidge of what we teach you most of the time. You apply very little of what we teach you in the main decisions that you make in your life. I bet you that you believe TikTok much better than you believe most of your professors in terms of the things that you actually do on a day-to-day basis. Why? Because TikTok is questionably, in my humble opinion, making you have fun. Everything we tell you is no, no, no. We are the merchants of doom. Don't travel, don't do that, don't drive, blah, 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 don't drink, don't do. So nobody wants to do what we tell them to do. Because everything that we are doing are problems that you might not even be looking and understanding are your problems. Is climate change your problem? Has your house been flooded? Have you run out of water? Have you gone to the hospital because it was too hot and you didn't have air conditioning in your house? It's not our problem, is it? It's somebody else's problem. So it's very hard for us to realize, internalize, and normalize impacts of climate change when we don't feel it. It's an invisible problem. But I can guarantee you it's much less my problem than it will be your problem. I'll probably will be dead when you are going to be facing a lot of the, I'll have committed the ultimate adaptation. I'll die, I'll not be here. I have totally adapted. But for you, it's going to be choices, choices, choices. And how do I protect myself? So would you move to Florida now? Not for political reasons, but for climate change reasons. Would you choose to buy a house in North Carolina, in the coast, if you don't know how long that will last? If the government is going to move you out of there. There is a lot of talk now that people are going to move into the Great Lakes. The Great Lakes is still losing people left and right. So many more people are leaving than they are coming in. But there is a lot of conversations that when they cannot live in the Southwest, when they cannot live in the coast, they're going to live here. They're going to be your neighbors. Do you want more people living in your cities? And if they live in your cities, are they going to be competing with you for the resources that are already here? So those are all problems that we can't feel very closely because they are not in our horizon, but they are getting here. My job is to think about them and try to think about ways of increasing our capacity to respond to those issues. The main climate change adaptation issue in the Great Lakes states is infrastructure. So we don't have very severe drought. Well, it's a little bit paradoxical to talk about drought in the Great Lakes, but there is drought in the Great Lakes in some definition. We don't have lots of horrible flooding, although there were the flooding in Detroit a couple of years ago. There is more and more flooding that people are looking at and hearing about. We don't have sea level rise, We have lake variations. And we don't know if the lakes, well, we know that the lakes are going to go up and they're going to go down. It's the rate of variation that is going to be affected by climate change. So 5 years ago, there was no beaches in the Great Lakes. How many of you have gone to a beach in the Great Lakes that was the size of this guys here? Huge beaches becoming here, and houses that were very far from the water being covered with oh my God, I forgot the word. No, areia. Sandbags. People putting sandbags in front of their houses. We actually saw a house on stilts being moved down on the beach because now the water is abutting with the house because of erosion, beach erosion. So all of those things are a fact. Another effect, how many of you have gone to beaches in the Great Lakes and saw all that algae? Yucky algae. That is going to get more algae and more cyanobacteria, which is actually not just a nuisance, but we call nuisance hab, something that you don't like because it gets in your way to go to the water or walking on the beach, but actually poison people, poison water. The city of Toledo, 4 days without water because of cyanobacteria in 2015. So all of those things are going to become more frequent, and then we have to pay attention. So how can we build this capacity? So here's the thing. Scientists are great people. I am one, my husband is one. I have this joke that I have a PhD in atmospheric sciences by marriage because he's a meteorologist. I'm a social scientist. So we are the perfect couple to study this. But we are great people. We do great research. We know a lot of things, and we are hoping to know more and tell people what to do. People don't want to be told what to do most of the time. And most of the people who are making decisions that are very important for us, planners, water managers, farmers, they have been making those decisions for their whole life. And those decisions have worked perfectly for them. They don't need other people coming to them and say, change everything that you do. It's a nuisance when you change everything, isn't it? So there is a lot of resistance. So knowledge is there on that left side, my right side, your left side of this graph. It's being produced and bombarded, published in papers, in webinars, in policy briefs. We are all telling people knowledge, 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 knowledge. And then people on the other side who are making decisions are using other kinds of knowledge, other kinds of information. They are not seeking our information. Most of the time, they don't think they understand what we say, and they are not dumb. We can't communicate science very clearly. We are not great communicators. We are not trained to communicate. We are trained to teach, not to communicate. We are not great listeners as well. And we always think that everything that we do is useful. This is another joke. I don't know one single person that goes to the office every day and says, I'm going to produce a completely useless piece of information today. We always think that we are discovering the next best thing, because we are good at what we do. When you go and you talk to the decision makers, they have no relationship with scientists for the most part, because they don't read papers. They don't have time to read papers. They don't understand the papers because the papers are very jargony. We write to each other. And the more jargony it is, the better our cachet is in terms of prestige. So this has to change. It has to change because if we believe in sustainability science, that science is about solving problems, we have to talk to the people who are solving problems so that they can tell us what they need and what they do. And then we can think about what they need and what they do when we do our own science. Because many times it's an adaptation question. It's not that our science is disconnected, it's just badly put together in order to be actionable, okay? So this is a theoretical paper that I wrote with 2 students in 2012, and that's started myself in this journey. How do you then bring those two sides together? So lack of use of scientific knowledge is for two main reasons. One is fit. What you're telling me does not fit my decision-making model, and therefore I will ignore it because I don't know how to make it fit. Climate information is the quintessential, isn't it? You put all those curves of huge bars of uncertainty, and you go to a city planner and say, we are not completely sure it's going to happen, but we think that it's going to be, more rain and more heat. And then an engineer who's trying to retrofit their stormwater management asks, so how much? How much change? How much more water in 20 years? How much more water in 50 years? A climate scientist cannot tell you that because the models are not good enough for that. The models are good to tell you that there's going to be more water and there is going to be more heat. They are also improving, but not enough. Every decision maker wants to know what's happening exactly where they are. It's place-based decision making. It's your city, your farm, your water system. And we don't know if the rain is going to come here or it's going to come in the next city. That uncertainty tells me that the only good decision that I can do is to prepare for the worst all the time. Why don't we prepare for the worst all the time? First of all, remember my umbrella story. We don't know. Second of all, it's extremely expensive. You cannot prepare for the worst all the time because you have all these competing needs. You have to take care of police, you have to take care of education, you have to take care of parks. You cannot prepare yourself for the worst all the time. It's invaluable. So what happens is that how do we get in that sweet spot in which we care about fit and we care about decisions that people do? So the co-production space is this space in which we believe that if decision makers talk with scientists and scientists talk to decision makers, and they can co-produce knowledge that is good for decision making, but also interesting for scientists, something good will come from this. So that is the space. You want something that goes from useful, which is what we think as scientists we are producing, from usable, which is what decision makers actually use, to use. We want the knowledge to be there. But then there are many, many constraints for that to happen. There is uncertainty, there is lack of skill, there is timing, there is cost, there is lack of people to do these kinds of research. So we know a lot about those barriers. But things that are really, really important for us to think is this idea of fit, credibility. Who is telling you to do what? Is that person credible? Am I more credible than TikTok? Don't answer that because I really don't want to know. But that is a question that scientists think all the time. Is it legitimate what you are telling me to do? Who produced this? Only white men in suits in their office, or was this information produced with everybody in mind? Diversity, inclusion, plurality, equity. So is this legitimate? Are you telling me to do something that I should trust? Should I trust your information? So this can only happen when there is two-way communication, customization, tailoring. So I have this great finding from my research. How can I make it better for you? How can I tailor it for what you need? How much more work I have to do? What is the value added that I can do engaging with you that will make this knowledge more actionable? At GLISA, that's what we do. We are the intermediates between science and decision makers. We are trying to customize, we're trying to tailor. We need to really scale this up really, really fast because we need a lot of knowledge. We have problems that we can't solve right now, and these problems are becoming more urgent. How can we do more of it? My outfit is so small, GLISA is so small. How can we have 1,000 GLISAs in the US for people working? That is something that for you could be a future, being an intermediate between, an academic world and a practical world. Because what we need is these good communicators in the middle, brokers, information brokers, intermediates that could understand the science, but also understand the other side. So we need to disseminate co-produced knowledge. We need to aggregate impact. We need to impact the largest number of people possible. But co-production is slow, is small. So I have like 5 staff at GLISA, plus a co-director, plus me, and a bunch of other scientists. So how can we increase and accelerate and scale up this kind of processes? One way that we can do that, I don't know how to jump, so one way that we can do that is to have these boundaries. So what we do in GLISA is that we, every couple of years, we have like a small grant competition in which we give some organizations $20,000 for 2 years, $40,000 maximum, for them to organize a number of decision makers and play this role of intermediate, because we cannot do that ourselves. So we are disseminating it by hiring other people to do that for us. But building trust takes a long time. So we invite organizations who already have communities' trust to work for us by giving them grants. So we have boundary chains. That would be our dream model, in which so many of those boundary organizations are helping each other that they don't need us anymore. They can network with each other. We give those small grants for organizations such as MSU Extension, who already has the trust of farmers. We give them for Detroiters Against Climate Change, who already have the trust of communities in Detroit. We give them for the American Association of Adaptation Professionals, who already have the trust of adaptation professionals in cities. And they help us to disseminate the information rather than us doing that ourselves. Another strategy, can we do that remotely? Do we have to co-produce everything face-to-face? Can we co-produce over Zoom? So this is another experiment that I did, looking at different forms of communication with a computer, with a webinar, and face-to-face to see what was the difference. How much time and money would you save if we could talk to somebody on the computer? You know that, don't you? It's harder for my generation, but younger generation have a very good relationship with a computer. They can actually develop very meaningful, trustful, sometimes too trustful, to be honest with you, you have to be careful, on the web. So how can we harness the power of remote communication to co-produce with people who want to use the information? Another thing, so this is a large project funded by the USDA with farmers. If we can produce a decision-making tool with farmers to adapt to climate change, if we can co-produce scientists from the university, this was Purdue University, University of Iowa, Iowa State, Purdue University, MSU, and University of Michigan. If we can co-produce with a number of farmers in the Midwest, 5 tools that are good to adapt to climate change, will other farmers use it because it was produced by farmers rather than just scientists? So how do you understand that? So we co-produced it first, and then we did a series of campaigns to disseminate it amongst other farmers. And we would ask the question, why are you using this tool? And a lot of them told us that they would recommend the tool to other farmers. So is that the way to do? Is that to incentivize? How many of you do things because your peers are doing those things? So how can you actually contain, use contagion as a good thing rather than a bad thing? But is it legitimate, illegitimate? But if farmers are involved, are you more likely to use it? And they told us yes. This is another relationship that we have with cities. It's called the Great Lakes Adaptation Network. We support them with a little bit of money, and there are 36 cities in this network, and we are in constant communication with them. And we produce several products for cities on our partnership with them. And they are doing great things in their cities. Ann Arbor is a member, Grand Rapids, another member, Buffalo, Grand Rapids, Madison. So a lot of cities that are on the forefront of responding to climate change are part of this group. And they all learn to each other. You know, it's a little bit of the frenemy thing. They compete with each other and they collaborate with each other. So cities all compete with each other. But if one city does one cool thing, the other city wants to do the cool thing as well. And that's a good thing. Again, another form of contagion that can go on without us being there all the time. Okay, so that is what scaling up is all about. And that's what I'm trying to do. Okay, so we work with stormwater management, we work with urban forestry, we work with heat islands, mainstreaming different packages of decision making. We look at the role of politics, of entrepreneurship, people working in cities, people working in other agencies that can be our ambassadors, that can be our brokers on this effort. Okay, so, I think I have only 2 more emails. One slide. I have like 100 emails, I'm sure. So what is the problem with co-production? So it's a very good thing. People should be doing more of it. One problem with it is that now it has become a little bit of a mantra. Everybody wants to do it. They don't know how to do it very well. And it's creating a little bit of anxiety in scientists, the idea that they have to talk to people. So I actually have colleagues that are really beleaguered and anxious because they went to academia because they didn't have to talk to anybody. And then all of a sudden now they're expected to talk to everybody, you see? So it creates a little bit of a conflict. The idea of co-production is for those who want to do it. Not everybody has to do it because not all knowledge is co-produced and not all co-produced knowledge is used. So I think that we need it, but we don't need only it. It's just one more tool in our bag to do it. What are other things that are complicated? Issues of justice, issues of equity are very rarely contemplated on those relationships. And they need to be in. A big problem with vulnerability is not only poverty, but also exclusion, also lack of diversity, lack of justice. How do we bring this in this world of climate adaptation? It's fundamental that we work in that direction. Another thing, there is a stakeholder fatigue. You are always knocking at some door. The sustainability director of Ann Arbor, she was my student for many years. I was in her PhD committee. She goes away when I knock at her door because she knows that I want something from her because she's awesome. But awesome people is the people who everybody wants to talk to, you see? So there is this fatigue. She has a full-time job. She doesn't have time to be talking to me anytime that I have a brilliant idea. Say, ooh, Missy, do you want to do that with me? You see? So there is this issue as well that we have to be really, really careful about. It has become a little bit of a gold standard. And a lot of people in the basic science have this perception that is devaluing basic science. It used to be the basic science was the pinnacle, applied science, they're not so respected. Now there is this shift. And I am completely against it. I think all sciences are important. And they all have different roles. They should be there. There is no applied science without basic science. Not everybody's cut out for this. But the biggest problem is that when you are cut out for this, how are your university helping you to do that? Are they paying you more because you are engaging? Are they giving you more time for tenure because you're engaged? It's a huge toll in an assistant professor. On top of publishing and writing proposals, have to do all this work. Are the universities helping you to do that? How are they valuing it? How are they counting engagement towards your promotion, towards your professional training? Okay. So very, very, very fast here. The other thing that we need is to evaluate those actions. We do that a little bit in GLISA. We need to do more. We are spinning all this work. Now we have to evaluate to see if it's really, really much better. So there is a lot of focus, not a lot of of evaluation, and we need better frameworks to evaluate. We also need equity. We need this idea of politics. I've already talked about it. We have also to compare between different strategies to see where they yield the best outcomes. And we have to have in our minds, how can we be part of this? One thing that I have done since 2010, I've never applied to one stitch of money, neither from NSF, from NOAA, from USDA, that did not allow me to do something that was good for decision making. I just made a decision, and people are giving you money for that. NSF is changing the way it gives money to include more engagement. NOAA and DOE, DOD, they already do that. So you can make this commitment. You as future PhDs, if you want to do that, you can make this commitment. Maybe you won't have the choice anymore. I hope so. It's a little bit mean. No, I hope you have choice. But I think that one thing to think is that this is a new world. We have to keep pace with it. The problems are huge, but I'm an optimistic. I think that we have ways to solve it, and this is one way to do that. Thank you very much. Okay, I meant to speak a little bit less, but we started a little bit late as well, didn't it? Yeah. Okay. Questions? No, not from you. It's okay if they don't have questions. I'm fine with it.
It's a question.
Okay.
You mentioned politicians in the USA sometimes just don't believe in climate change.
Mm-hmm.
Have you seen that in other countries on the same scale?
Not in the same scale. There is a lot of research about it in other countries as well. You know, in Australia for a while, there was a very conservative government, there was also very conflict. So let me qualify. I actually don't believe the politicians don't believe in climate change. I think most people believe in climate change. I think it's not expeditious to do something about climate change because the timing of the decisions, it won't get you popularity contacts. You know, even presidents want to do something like that, like President Biden now. You see, it's one step ahead and one step behind. So I think people believe in climate change. I think they don't want to do anything about it. And one way then to have an alibi not to do something about it is to deny that it is there. But, I think that people will disagree about many things about the science of climate change. And there is more to do that because it's a science that still has a lot to improve, especially the science of impact. The science of climate change is reasonably well, but the models are very bad. You see, so I think that it's very healthy to question the science of climate change, but not to question the existence of climate change.
Your research now is, are you focusing on like seeing if methods you're doing in your work, or is that what your research is focused on?
Some of it, I try. So here's the thing. A lot of agencies will give you money to do an experiment. They don't give you money to go back 5 years later and see what happened. Okay?
Yeah.
So, and when you evaluate, you need time for things to happen. So most of my projects are doing evaluation right after and collect data right after because, God forbid, somebody gives me the money, I have the baseline data to compare with the next one. So I have a project now with 60 cities in the Gulf region of the U.S. We did an intervention, the intervention just finished, and we are analyzing data. We are collecting primary data because one of our goals is to go back to the agency 5 years and see, so what was the impact of what we have done? At least I can do a lot of that, but this is small projects because then I have the money to do that. So we work with the grade 12 students and the grade 8 developing a tool for stormwater management. That was easy. So we can get a phone and I said, you have an hour. Tell me what you have done with the tool. And it's amazing because usually people do a lot of things and many things that we didn't even thought about. That was going to be, we thought, okay, they're going to evaluate their stormwater system. Yeah, check. Great. That's what we meant it to be. But they have used it to advocate for money. They have used it to advocate for more personnel to help them to do things that they need to do. They have used it to increase budgets for other areas because they think, okay, those things are connected to each other. They have used it to go to Eagle, and start new projects with the state mission. So a lot of things that we did not think that would happen have happened with that. And I think that's what's important for us to do. But very rarely the system will give you money to do that, if the project, especially if the project is big. Yes?
So with the research and the study and stuff that you did in Brazil with the families, is that really what inspired you to start teaching others of how they can help combat climate change?
Oh my God, no. I think that the research is very important because I think the results are fantastic. I think that since the beginning, so I started, my PhD was on pollution. When pollution was a bigger thing. So climate change, global warming is pollution, CO2 is pollution. So I haven't completely left it. But I changed because, well, actually, you may be right. I remember another story. My first grant from NOAA, I got because director of a program at NOAA came to the university that I was teaching at the time, which was the University of Arizona in Tucson. And he presented data on this Brazil project, 1997. And he said, look, we did this forecast for El Nino. We told the farmers that El Nino was happening. They all adjusted their planting, and they were not spending enough. They were not hungry anymore. I thought that was not true. The minute I said that, there's something funky with this graph. I'm sorry, because I knew a little bit of the region before. So I came to the podium after the talk. I don't have any money, so you don't come to me after this podium because I don't have any money. But he had a lot of money. So I came to the podium after his talk, and I said, I don't believe that graph. He looked at me and I said, my mentor at the time, I was a postdoc. She looked at me with a dead face and she nice. So this is like a big deal from me. I was so clueless. I just said what I wanted. And he said, you know what? Why don't you write a proposal and make an honest man out of me? That's exactly what he said. So I wrote the proposal and I got my first grant out of that situation. So in a sense, it did inspire me to shift into this area. But they need to do something about climate change. I think it's about your future. You see? Because it's very unlikely that my future is going to be as affected as your future. And here's the thing. It's all about timing, isn't it? How many times you bought a ticket to travel somewhere for spring break 1 week before spring break and it cost you more than $1,000 that if you had bought that ticket 6 months before? Every time that you run out of time, you make bad decisions because you're pressured. Everything is that. And that, I think, is the problem with climate change. We are still in the horizon that we can make some smart decisions. We are not making them fast enough. We are making some smart decisions, but not fast enough. On the other hand, they are going to get worse and worse and worse, the decisions that we make. At one point, governments are going to regulate climate change. You cannot travel anymore. And that's going to be bad, isn't it? Or I'm going to ban gas from your houses. This is a big topic now, isn't it? People love their gas stoves. Or you can't drive anymore. Or, so we still have time to make reasonable decisions that will make us meet our aspirations. But as time goes on, we might lose that ability to make those decisions, and that's not going to be good. I do have a lot of hope in Generation Z and millennials, to be honest with you, because there is a lot of research out there that says that there is a true shift in consumption on Generation Z and millennials in terms of wanting less things, which is very healthy, wanting less things. And actually, there's also very good research that tells you when you have fewer things, you are happier. It's the art of wanting less. That's how they call it, you see? And it has good data about this. That when you have fewer things, you are freer. You have more freedom. So there is a very smart Indian economist who won the Nobel Prize, first Indian who won the Nobel Prize, Amartya Sen. That's the name of his book, Development as Freedom. I think it's a beautiful book. I really advise everybody to read it. It's so beautiful because that's what he says. Once all your needs are met, you can regulate your wants. And wanting less is being happier in many, many situations. And we have to respect that. If you think about all the youth movement about climate change, what they call the Greta Thunberg effect, actually there is this sentence in the words of research. I am editor of a journal. Every week there is an article that says the Greta effect. And it's a real thing. It's a real thing. It's a powerful thing. I know my son doesn't want to have a car. I was so relieved the day that he told me I'm not going to drive it. And I did a little dance inside, of course, outside. Yeah, that's but that is the thing, isn't it? How can we actually act upon ourselves, thinking about the future, think about the peer effect, think about the influence that you have on the world as voters, as decision makers, as future scientists, and think about those things that other scientists are telling you as well. It's amazing how, as scientists, we believe our science, but sometimes we don't believe other people's science. Isn't that true? So I think that part of the things that we have to do is to respect, behavioral science as well, and telling you that some of those things are real, and they have a huge effect on the world. Okay. Any more questions? All right. Thank you.